Hello, maurieos 2018 Land Surveying 1 Travis Assignment Review. Hello, welcome. Well, I've been asked by a number of students to do a Travis assignment review, similar to the one that I did for the levelling review, as students found that particularly helpful when trying to complete their assignments. Well, here it is. So let's see what we can do. So first of all, I think that I'll go through the actual Travis itself, even though I have done a briefing. Some things have maybe changed over time, just so we know where everything is. And then we'll take a look at a student report from a previous year, and then we'll have a look at my survey report template that I put up, because that's pretty important as well. So let's go over to the big screen, and first of all, where do we find it? Well, it's under assessment here, and under traversing, that's where it all is. And you'll see in there a number of files. There's the briefing and the assignment itself there. So I'll just work through what's here. The assignment, there's a BTEC and an NZD assignment because there's different requirements. Survey control plans, an older one and then a newer updated one. Some examples of the field notes, and they pay there, so I probably need to pay particular attention to them. And then a Travis spreadsheet, how to do the Travis spreadsheet in 12D, some videos on that. A video on topographical reduction for 12D input using this topographical survey reduction sheet here. And then some little 12D things, particularly for the BTEC students who are required to work out a volume of the stockpile. And then also here a little AutoCAD template that you can use, and some ideas on quick AutoCAD plots. My survey report template for traversing, I seem to have put the levelling one in there as well for good measure. And then down here, observing procedures. That's something that came up during the course of things as to how to go about it, and the thing here. So one of the first things that I would look at is the actual, I'll look at the BTEC one, because that's the most that's the highest spec one, but the NZDE one's slightly different, but that'll cover off everything. So I just wanted to look at the assignment, and just in particular look at the marking schedule, which is different for each one, but you can see that the marking schedule is broken up into two parts. One part is the practical part, which is largely done by attending classes and getting them signed off and submitting the signed off sheets, not only with your worksheets but also with your assignment. And then we come to the report, which is again, it's worth about just under half. And then don't forget the team scoring sheets as well, because they all come into it. So you can work through here and you can see that the various things that are required: health and safety, the origin of bearings, coordinates and heights, survey work accuracy, finder diagrams, Travis sheets, topo data, stockpile has been calculated and reported, plans and diagrams, and survey marks are named, and what have you, and various bits and pieces in there. Complete set of field notes here. Now that's with standard page numbering and diagrams and things such as that. So the marking schedule is a very good guideline as to what you want, and almost a schedule of what to do. Just remember that each one of these criteria is marked out of 10, and from that I'm able to determine a mark. So that's just wanted to draw your attention to that. The other thing that I wanted to draw your attention to was the field notes, having a lot of questions around those. So the field notes, this is a set of well, there's lots of ones here, but this is an example field notes here, just from a cadastral type Travis. So there's no heighting in this one. But what you see is what I wanted, and that is you have your field notes, or the written part on this side, and a diagram on this side here. Now what happens is you do all your various calculations and things and come up with your reduced bearings and distances and in this instance, and then you write those reduced bearings and distances on the diagram, rounded appropriately. So when you come to do your calculations on your Travis sheets and what have you, you use the diagram where you've distilled down all this information and you have sort of clarified it so you're not confused by all these numbers and things. Now each page, you can see there, that's 2 of 3, and if you drop down another page here, that'll be 3 of 7, sorry. And on each one there's a diagram that represents the survey work that's on the page on the left. And that's what I call a complete set of field notes, with diagrams completely filled in here with the names of the people and everything reduced, and yeah, fully worked there. And that's what I'm expecting for the field notes. And the field notes, should be, once the field exercise is complete, then it's just a matter of drawing the plans from the field notes, and not the other way round. So yeah, that was just what I wanted to say about the field notes, and we'll drop back into the Travis thing. So I mean, that's a pretty quick run through of all of the stuff that is there. Now, and I'll come back and have a look at the report. Now, what I want to do now is, oh, don't forget you've got the job instruction there, and that might be worth a look at as well, because that tells you what's required, what your manager said. So, coordinates and heights of all marks and points, find diagrams of new Travis marks, so not any old ones, just new ones, and Travis sheets detailing measurements and boundary dimensions, calculation sheets showing bearings and height closures, a set of plans and diagrams, and calculations showing how the stockpile volume was determined. So that gives you a pretty good idea of what's required there. But perhaps the best idea is to look at a similar report that someone else has done. So let's just see here if we can locate something along those lines. So I'm going to have to go here to the Travis thing, and I think I have to go back to 2017 and for the Traversing assignment there. And this is, I've got a final student example here. So this is I'm just going to do Control 0, which gives it there. So this is the Travis report here, right in here like so, and then we can just page down through that. So yeah, nice little report. Now this business here about scope, origin of bearings and that sort of thing, I will cover that in my report template, which I have produced since this was done, and that will give you a better idea. Now, and you can see that this guy has covered off origin of bearings and heights, and the methodology. The methodology should be just enough to tell the client how you did it, not going into too much detail. So the equipment, just the basic equipment that you used. You don't need to go into what sort of hammer you used, or the you know, how big your spade was, or that sort of thing. just quick information that gives them a reasonably good idea. Now, in this particular report, they've chosen to put a lot of the data, like for instance adjustment data for bearings and things, onto little spreadsheets and put them into the report. A good set of field notes, a complete, fully worked set of field notes, is as good as, is acceptable. They've done this, I think, because the field notes became a little bit unwieldy, and so this sort of helped to clarify it. And it's it's not a it's okay to do it. It's not a compulsory sort of thing, but certainly it brings home a number of things like the bearing misclose there. You can quite clearly see the coordinate misclose here as well. So these are and done in a nice consistent fashion in the report. And then here you've got the height closure as well, which is has been well done to give you the adjusted RLs of each mark, and it shows sort of how it does. So this can be done on the field notes or in their health and safety, of course. Now this is the 12D Travis sheet. So the Travis sheet has been done in 12D, and then so they've done their Travis, which gives them their Travis close, and then the radiation to all the posts that they did, probably added in any posts that they missed, and then calculations post to post, just to confirm that the boundaries are all good and going, and your measurements and vectors are fine. So that's what we've done with the boundaries there. And then the next thing that they've done, of course, is then recorded the topo shots on the spreadsheet that I provided. So it's just a matter of once you've determined your instrument height, your reduced level and coordinates of the point that you're at, then and you put in your instrument height, type in your data, and there it is. It's all in there in that particular spreadsheet, like so. Now you'll need to have a separate sheet of the spreadsheet for each mark that you set up on. And then here's his calculated the stockpile volume. This was a BTEC student, so that was one of the requirements. He's then also taken the data out of 12D and put it into a basic AutoCAD plan there. It's more of a diagram. You can see the stockpile is here and underneath, and everything there's all pretty good. So notice that the black lines around the logo are missing. It's a bit of a problem that I have. So you need to send the logo to the back and the black lines to the fore. Just a little glitch that might be sorted out one day, but something you need to be aware of, little details. And then a separate little plan of the stockpile with the various heights and things on that. He's then finished off the report, so quite a nice tidy report there with recommendations, that there sort of thing, and a conclusion, and then a list of his attachments. Now there's the field notes. In my opinion, the field notes would need more work to meet the standard that I have set there, but and you can possibly see why a little spreadsheet or something in the things was used, as these are they've had a fair bit of work done to them there. So there, and then there's for each field note he has done a diagram. So page field note diagram, diagram. I think you get the idea there of what's going on there. Field note diagram and so on, and then these are the topo stuff there, which has been keyed in, and then this is a little just an overall look at things as to how for location, find a diagram for peg 1. It was a little bit out isolated there, so but not really much to measure to. just to orientation, so a little diagram that was added there, and that one for PEG 2 and so on. Some health and safety documentation there, which is all marvellous stuff. And then it comes to these. Now, obviously, if this was a report to the client, you wouldn't have these in, but these are essential. I want these at the back of the report so that I can mark off the practical work with some confidence that I've seen you do it and perform the operations. So that was a little exercise there, and there's a Travis sheet. That was the exercise at the container with the 3 reflectors on the posts that he's put in there. So perhaps not really necessary, but there you go, it's all signed off. So that's the student report that I've sort of had a look at there. And now we'll just go back to a Moodle here, and just to go through a couple of things. I wanted to just have a look at the survey report template traversing, which I've put there, and that should be coming up in Word now, or as a template. So here it is coming up now. So, well, there we go. So this is my, and I'll just go view, one page view. So this is what I've put up there as a report template. So a nice little photo on the front if you can. Executive summary, which just summarises your job and how it went and that sort of type thing there. The scope, instructions, what instructions, so the existing data, well, that would be all the plans that I gave you. The equipment, just the main equipment, so it might be like the total stations, probably all you need. You might include the GPS if that's part of the stuff that you're providing, but generally just the total. The origin, so the origin of bearings, state the bearing projection datum and an origin of bearings, if one exists. So I've left out the if there. So obviously bearings are in terms of, in this job, bearings are in terms of geodetic datum 2000 on the Mount Eden 2000 circuit. Now each of you will have a different origin of bearings, so the origin of bearings might be say from PEG NL to MB, using or MN or something like that, using bearings calculated from the coordinates shown on the Zealandia Park control plan, with a check onto the line NL to BB, using calculated coordinates, using bearings calculated from coordinates obtained from the Zealandia Park control plan. So you've said what your datum is, geodetic datum, New Zealand geodetic datum 2000, Mount Eden 2000 circuit, and then you've said the actual data that you think, where the values came from. You might even show the actual bearing there. Origin of coordinates, again, New Zealand geodetic datum 2000, Mount Eden 2000 circuit. The coordinates are in terms of New Zealand geodetic datum 2000, Mount Eden 2000 circuit. The origin of coordinates is PEG NL, using, and you might put the values, using values obtained from the Zealandia Park control plan provided by the client. Origin of heights. Heights are in terms of Motoriki datum. The origin of heights is PEG NL, using values obtained from the Zealandia Park control plan. A lot of repetition there, but very clearly that you need to state the datum or the projection, datums and projections, and then the actual values that you use. So it's very clear. Health and safety. So talk about that. I don't think that's going to be a big problem. How your survey control was established. The boundaries is what you did with regards to the posts. So you measured radiations from your control points to the posts, and then calculated the boundaries to compare them with existing values to confirm that the boundaries were all correct or intact. Topo details, how did you do those? You set up we're done there, and just describe there. You might say what feature code you used and that sort of thing. Survey marks, you might sort of say what sort of marks you were and note anything about the marks, like for instance that the mark might be in need of repair, or the mark has been removed, or something like that, or it's been damaged, and that needs that sort of thing. Accuracy, you need to talk about your bearing close, how good your bearing close is, your coordinates, how good your coordinate close is from your Travis sheet, and your height close, how good that is. Conflicts might be if you disagree with boundaries or values or heights or things like that. It's usual just to discuss them and point out how you've dealt with them, and how you plan to, you're giving your client a good product going forward where these conflicts have been resolved. The outputs, so what are you giving the guy? What is expecting in the report? Plans, what a list of plans and things. Documents, what documents they are. Digital data, this is just computer files, digital data on a flash drive, or you might be emailing it might be on your Dropbox, you might whatever, but where it is, how the person can locate it. You might want to make a comment that you're quite happy to, say, reformat the digital data into an acceptable format, just let you know, that sort of thing. Keep it sweet. Recommendations. You don't have to recommend things if everything went well. You think that it's good, say so. But if you think that there's something that that could be done that would make things better, but weren't within the scope of what you're doing, you could do that, or that sort of thing. So you're trying to sell your company, sell yourself, and that sort of thing. So it's fairly important that and put positive things. Don't sort of say things to the client that would suggest that you did a crappy job. Don't sort of mention things about how you the handbrake slipped and you drove through the gate, but you've sort of bodged it up a bit and the cattle won't get out. You sort of keep it positive, or that sort of thing, or there's huge misclose or that sort of thing. So keep it positive and good recommendations. And conclusion, summarize the job, thanks for the opportunity, would welcome further work, be very obliging in that, and then your list of attachments and what have you. So that's pretty much everything, really. I think that's a fairly quick review of things. I think that covers most of the key and salient points. If you have any problems, you can always make a comment in the video below, or you email me or something like that, and I can do an update. So I think we'll just leave it all there, and just let the wonderful Zealandia Park speak for itself as it on after a little bit of rain there. It's quite picturesque, actually. A few little ducks bobbing along across there would not be out of place. But so all good. Cheers. I hope this meets your requirements. As I said, if it doesn't, let me know. All good. See you.